50 years, we knew something monstrous was hiding at the heart of our galaxy. We could feel it, in the way stars accelerated beyond anything that made sense, in the way space itself seemed to bend around an invisible point. We knew it was there. We just couldn't see it until May 12, 2022. The center of the Milky Way sits roughly 27,000 light-years away from us, tucked behind the constellation Sagittarius. And right at that center, not near it, at it, lives one of the most extreme objects in the known universe. Astronomers call it Sagittarius A star, written Sgr A, where the asterisk is read like a star, a nod to excited states in atomic physics. An oddly poetic name for something this violent. Sgr A is a supermassive black hole. Its mass, approximately 4.3 million times the mass of our sun. That number is hard to hold in the mind, so let's make it physical. Its event horizon, the boundary beyond which nothing, not even light, escapes, has a radius of roughly 12 million kilometers, about 0.08 times the Earth-Sun distance. If you placed Sgr A where our sun is right now, that horizon would extend roughly halfway to Mercury's orbit, halfway to Mercury, and it sits at the center of the galaxy we call home. Here is the strange thing. Despite being the most massive object in our galaxy's core, Sgr A is completely invisible to the naked eye, completely invisible to optical telescopes. You could point the best ground-based camera directly at it tonight and see nothing useful. Between us and the galactic center lies 27,000 light-years worth of gas, dust, and stellar debris. That wall of interstellar material absorbs and scatters visible light so severely that the galactic core is extinguished by a factor of roughly 1 trillion invisible wavelengths. 1 trillion times dimmer than it would otherwise appear. The only way through that veil? Radio waves, infrared, X-rays, wavelengths that pierce the dust where light cannot. So for most of human history, and indeed most of scientific history, the center of our own galaxy was sealed behind an impenetrable curtain. The curtain began to lift in 1974. In 1974, radio astronomers Bruce Ballack and Robert Brown were scanning the galactic center when they detected something unexpected, a compact, intensely bright source of radio emission at the precise center of the Milky Way. They named it Sgr A. Brown coined the name. They had no way to know they had just found the address of a monster. But a radio source isn't a black hole. You need more than a signal. You need motion. Starting in the 1990s, two independent teams, one led by Reinhard Genzel at the Max Planck Institute, the other by Andrea Ghez at UCLA, began an extraordinary patient vigil. Using infrared telescopes that could peer through the galactic dust, they watched the stars closest to the galactic center, year after year, decade after decade. What they saw was astonishing. Those stars, dozens of them, were tracing tight, high-speed orbits around a single dark, invisible point. There was nothing visible there, but the gravity was unmistakable. One star in particular, designated S2, became the key witness. S2 completes a full orbit around Sgr A in roughly 16 years. At its closest approach, in 2018, it passed within approximately 120 astronomical units of the black hole, and it was moving at around 7,650 kilometers per second. That is 2.55% of the speed of light. Think about that. A star the size of our sun, hurtling through space at nearly 3% of the speed of light, tracing an orbit so precise it could only be explained by one thing: an invisible mass of 4.3 million suns packed into a space smaller than our solar system. The gravity collaboration detected the gravitational redshift of S2's light in 2018, a direct fingerprint of general relativity at work in real time. In 2020, they confirmed the Schwarzschild precession of S2's orbit, the same effect that causes Mercury's orbit to precess, but now around a black hole. This was not a theory. This was a measurement. In October 2020, the Nobel Prize in Physics was awarded, in part, to Reinhard Genzel and Andrea Ghez for the discovery of the supermassive compact object at the center of our galaxy. The black hole had been proven, indisputably, before anyone had taken a single picture of it. But a proof on paper is not the same thing as seeing, and what the Event Horizon Telescope set out to do was to see. To photograph Sgr A, scientists needed a telescope unlike anything that had ever existed. Not because the black hole is small, but because it is so absurdly far away. At 27,000 light-years, the apparent size of Sgr A's shadow in the sky is roughly 51.8 micro-arcseconds across. A micro-arcsecond is 1/millionth of 1 degree. To resolve something that small, you would need a telescope with a dish essentially the size of the entire Earth. So they built one. The Event Horizon Telescope, the EHT, is not a single dish. It is a global network of 8 radio telescopes scattered across 4 continents, synchronized with atomic precision, all observing simultaneously at a wavelength of 1.3 millimeters. Together, they function as a single instrument with a resolution of roughly 20 micro-arcseconds. The EHT team put it this way: the resolution is equivalent to reading the date on a coin sitting on the surface of the moon. The data collected in April 2017 across 5 nights of observation filled 3.5 petabytes of hard drives. 3.5 petabytes. That is too much to send over any internet connection on Earth. So the drives were physically flown by cargo plane to central processing facilities. The drives from the South Pole Telescope had to wait. They could not be airlifted out until the Antarctic winter ended months later. Then came 5 years of analysis. Over 300 researchers, 80 institutions worldwide. The challenge was unlike anything they had faced before, not just in scale, but in the nature of the target itself. Here is where this story takes a turn that most people don't know. In 2019, the EHT had already published the first ever photograph of a black hole, the supermassive black hole at the center of galaxy M87, known as M87 star. That image shook the world. It showed the same ring of glowing plasma, the same dark shadow. But M87 star is a fundamentally different beast. It has a mass of 6.5 billion solar masses, roughly 1,500 times more massive than Sgr A. It sits 55 million light-years away, about 2,000 times more distant. And here is the strange coincidence. Those 2 factors, mass and distance, almost exactly cancel each other out. In the sky, Sgr A and M87 appear nearly the same angular size. But photographing Sgr A was dramatically harder. The ESO described it this way: imaging Sgr A was like trying to photograph a puppy chasing its own tail. The gas surrounding M87 star orbits the black hole over days or weeks, giving a stable, consistent image. The gas around Sgr A, because the black hole is so much smaller, orbits in a matter of minutes. The scene was changing during the observation itself. On top of that, 27,000 light-years of interstellar gas and dust between us and the galactic center scatter and blur radio waves. A problem M87 doesn't face because it sits far outside our galactic plane. So the EHT team could not produce a single clean image. They had to develop new computational methods, averaging across many thousands of reconstructed frames, to produce something stable, something true. On May 12, 2022, after 5 years of analysis, the Event Horizon Telescope collaboration released the image. It is not dramatic in the way we might expect from science fiction. It is blurry at the edges. It is small on a screen. But what it contains is extraordinary. A ring of hot, glowing plasma, gas heated to millions of degrees, spiraling inward, emitting radio waves that curve around the black hole's gravity before finding their way to us. That ring subtends 51.8 micro-arcseconds on the sky, and at its center, darkness. A shadow cast not by the black hole itself. You cannot photograph something that emits no light, but by its gravitational grip on everything around it. This is consistent with every prediction of Einstein's general theory of relativity. The shadow is exactly where the mathematics said it would be. We found the monster. But here's the thing about monsters. Sometimes the most frightening ones are the quiet ones. Right now, as you watch this, you are orbiting Sgr A. The sun travels around the galactic center at approximately 220 to 240 kilometers per second. One full orbit, what astronomers call a galactic year, takes somewhere between 225 and 250 million years. The last time the sun completed this orbit, the first dinosaurs had not yet appeared. And through all of that time, Sgr A has been there. Patient, dark, almost impossibly quiet for an object of its size. It currently accretes, consumes, only about 10 to the -8th solar masses per year. That is 8 to 9 orders of magnitude below what would be needed to make it the active, blazing quasar we might fear. It is effectively sleeping. So no, Sgr A is not coming for us. It is not consuming the galaxy. The idea that we are being slowly pulled toward destruction is a myth the data flatly contradicts. We orbit it. We have always orbited it. We are part of the same structure. In roughly 4 billion years, the Milky Way and the Andromeda galaxy are expected to collide. The two central black holes will eventually spiral toward each other and merge. Even in that scenario, the odds that Earth itself is destroyed remain low. The vastness of interstellar space means stars rarely collide directly, even during galaxy mergers. But that is 4 billion years from now. For 50 years, we track this thing by its gravitational shadow, by the way it threw stars across the sky like stones on a string. We proved it was real through mathematics, through Nobel Prize-winning patience, through decades of cold nights at infrared telescopes. But the image is different. The image is a face, a blurry, imprecise, hard-won 3.5 petabyte face, assembled from 8 telescopes scattered across a planet, carried home on cargo planes from the frozen end of the world. And what it shows us in the end is not a threat, not a catastrophe, not the destroyer we feared. It shows us the center, the anchor, the thing our entire galaxy has been slowly, silently orbiting for longer than complex life has existed on Earth. We finally looked it in the eye, and the monster was asleep.